Good morning, students. I am Dr. Eustace Russell, working as an assistant professor, the Department of Mechatronics Engineering at Sri Muthukumaran Institute of Technology. Today, I am going to give a video lecture in the subject called Engineering Mechanics, which is coming under the semester, that is odd semester, third semester. So hereby, I am going to introduce some of the few topics first. And in that, I have collected few topics and I will explain the important topics in that. We will see one by one. So, why this course has implemented to these students, mechanical engineering students as well as mechatronics students also, this paper they are studying. Main objective is they have to study the scalar and vector quantities, the techniques they have to study in that. And also they have introduced the equilibrium of rigid bodies and to understand the distributed forces also, that is beam and the intensity. And the fourth objective is nothing but in order to study the frictional forces at contact surfaces, various contact surfaces. And finally, the main objective is to study the dynamics, the concept oriented with force, momentum, and work and energy. These are the main objectives the students will study at the end of this course. From this slide, I'm going to give a glimpse about the syllabus of this course, Engineering Mechanics. First of all, Unit 1 represents the various statics of particles, and resolution of forces into the components. And main application of the Newton first law of force has been implemented in this unit. The student might have studied Newton first law in physics also, and that is the basics for this unit. And unit 2 is nothing but equilibrium of rigid bodies. In that we can study how we can resolve the forces into couple or movement by Verigran's theorem, one of the new theorem that is introduced in this unit 2, as well as the reactions of support and connections also the students will study in this, how the support reactions will act over the beam and various structural analysis so the students must study while doing some civil work or doing some design work, civil oriented work means the student might have know about this concept, why the reaction is acting at the end as well as support also. And unit 3 is nothing but we are going to study about the centroid, center of gravity, moment of inertia, as well as radius of gyration of the area, moment of inertia of the composite areas also by various integration process. Unit 4 is a very interesting one, that is a frictional analysis part. The day-to-day life we are aware of that, why friction is happening. When the vehicle is moving continuously, automatically the moving tire will get worn out. After some years you have to change it, as well as brake shoe also. After some years the shoe will get worn out and you have to replace that after the lifetime. The unit 5 is determining the dynamics of particles. As I already told, unit 1 focusing on Newton's first law of motion, and unit 5 is mainly focused on Newton's second law of motion. In this dynamics part will be get implemented here. In this followed by momentum, work and energy method, impulse and momentum, impact of bodies. These various concept you will study. Along with that, rectilinear motion and curvilinear motion also introduced in this unit. So in the upcoming slide we will see the important topics that is coming under unit 1. So basic definition I want to tell before starting that important topics. What is engineering mechanics? Engineering mechanics is a branch of science that deals with the behavior of the physical bodies when subjected to force or displacement. Whenever the body is there, when you are applying some forces, whenever the force is applied, something will happen to that body, whether the deformation will happen, otherwise it will move to some area with some magnitude, or some with the direction also it will get moved. That we will study in that. That is the branch of science that deals with the behavior. We are going to study the behavior of the physical bodies. And In the right hand side also, I have introduced basic types, engineering mechanics, that is statics and dynamics. These are the two important types. Statics is nothing but we are going to study the body which is under rest. Dynamics means the body which is under motion. Again, it is replaced by kinetics and kinematics. What is kinetics? We are going to study the behavior of the body which is at rest or which is under motion without considering the forces. That is called kinematics. Without considering. And kinematics is we have to consider the forces that is concerned with the moving of the body. I'll repeat once again, kinetics, kinematics. Kinetics is nothing but motion of the body. We are going to study the motion of the body without considering the forces, external forces. Kinematics means just vice versa. We are going to study the motion of the body, but without considering the, with considering the forces. That is called kinematics. Then statics is a branch of, it's a branch which deals with the forces and their effect on an object or a body at rest. As I already told, statics is coming under, we are going to discuss as a body which is under rest only, as well as dynamics, the bodies which are under motion. That I already told in the previous slide. The statics means the body which is under rest. Dynamics means we are going to study the body which is under motion. So this also we have seen. I already told kinetics is a branch of dynamics. It deals with the bodies of motion due to the application of forces. And kinematics is totally different. Without knowing the reference of forces that is responsible for the motion of the body. That is with knowing the reference of forces. Without knowing. That is called kinematics. Kinetics is due to the application of forces, we may know that. We have to consider that more forces that is active. So before going on to the important topics, going to solve one problem, also simple problem. In that basic problem, before that the student, you have to know about the basic SI units. That is International System of Units. Basic units we have implemented here. We are going to use basically mass, kilogram, length, meter, time, second, and force will be in Newton. And again, one important thing, if force is given in kilogram, how to convert into Newton? Just we have to multiply by 9.81 meter per second square. And vice versa, in order to convert Newton into kg means, just divide it by 9.81 meter per second square. This notation I have mentioned here. And the term also, the relationship, weight equal to mass into acceleration due to gravity, that is G. Here it is noted in the lower side of this slide, W equal to mg. Then again, this slide give a glimpse of all the units, basic units. What are the units basically we are using in engineering mechanics? Force mostly we will use Newton, work Newton meter. I already told the fifth unit is fully combined of dynamics. So whenever the moving part, its work is coming in the fifth unit, automatically the work energy, everything will be done in the fifth unit. That is Newton meter. Power, watt, energy, joule, area, meter square, volume, meter cube, pressure, Pascal. Mostly pressure we will not use in the engineering mechanics. In fluid mechanics, one subject only, we will include this, we will use this Pascal more. Velocity, meter per second. Acceleration, meter per second square. Angular velocity, radian per second. Angular acceleration, radian per second square. Momentum, kilogram meter per second. Torque, Newton meter. And density is very, very important. That is kg per meter cube. Couple is nothing but Newton meter. Couple moment, unit will be same. Newton meter will be used. What is the necessity of force? As I already told, whenever the force is applied, we have to see these major four characteristics. What are the major four characteristics? Direction, magnitude, point on which it is act, then the line of action. Line of action. When you are using the billiards game, with the help of one stick, we are hitting a ball. One ball will hit the another ball. And with some force, the next ball will try to hit the another ball. How it is happening? We are striking one ball with one stick only. Because we are applying some force with that stick in one ball, automatically the force will be transmitted to the next ball. That is the line of action concept. That is a principle of transferability. The force will be transmitted along the same direction of line of action. That is transmitted to the next object. That is line of action. Then as I already told, whenever the force is applied, under what direction it is applied, at what magnitude, how much magnitude it is we have applied in that. At what point we are going to apply the force, that also going to study in this. The top also it is mentioned, various contact forces, non-contact forces. So magnetic forces, electrostatic forces, these are non-contact forces. Everyone aware of that. System of forces, this is a basic classification. I want to explain about various system of forces. This is important basic definition part. They will ask this type of questions. What is coplanar and non-coplanar? Coplanar means a system of forces will act in one particular plane. Non-coplanar, the system of forces will not act in one particular plane, will act in different planes. What is concurrent? The forces that will act in one particular point, that is called concurrent. If non-concurrent means that forces, those forces, multiple forces will not act in one point. That is coming under non-concurrent. Then collinear, like and unlike. Parallel, non-parallel. Parallel means if two lines are parallel one another means we will tell that is a parallel line. As well as the forces also like that only. If two forces are acting parallelly, then it is parallel. If it is non-parallel means it is not acting parallel. What is like, unlike? If one force is acting in the right hand side and another force also acting in the same line of action, then is like. What is unlike? Just vice versa. If one force is acting in the right side, another force will act in opposite side, then automatically we will call it as unlike. This will be termed as unlike system of forces. The same thing will be implemented to this non-coplanar. Non-coplanar, as I already told, those system of forces will not act in a same plane, will act in a different planes. Then equilibrium. Whenever the system of force, we are telling that it is an equilibrium means, what you will tell? That resultant will be a zero. The resultant part will be a zero. That is the definition here it is given. The body is said to be in a state of equilibrium if the body is either at rest or moving at a constant velocity. Then what is the condition of equilibrium? That is the condition of equilibrium. The formula which is given in the slide. R equal to summation of horizontal forces, that is sigma h square plus sigma v square, that is the vertical forces. And here one basic line sketch problem, one real-time application problem is given over here. What is represents this sketch? One truck is there, and with the help of one pulley, various strings, the two men are lifting the goods with the help of a pulley, a long rope they are hanging at the edge. What is happening? The two angles is given. One is 30, another one is 50 degree. So everybody aware of that. Whenever the rope is attached to one point means automatic tension will be act in the string. That is TAC is given. Automatically the left hand side also one tension will be act towards that side also. That is TAB. What is 736 Newton? The weight of the goods that is we are going to take out from the truck. That is 736 Newton. And it is given as free body diagram. What is called free body diagram? Free body diagram is a graphical representation of the various external forces acting on that object. Acting on that object. That is a graphical representation. It is called a graphical representation of various external forces. As well as we can show the movement also. Movement, couple and various parameters we can put in the sketch in order to analyze the problem. That is called, in the simple form, we can tell as free body diagram will be termed as FBD, free body diagram. Here we took one basic problem. As I told in the syllabus, we already discussed in the first unit of the syllabus, resolution of forces into various components, into a resultant also. How we are going to replace into a resultant with a direction as well as magnitude. In this problem we are having a, we will aware of that what is the type of system of forces it is. It is concurrent. What is concurrent? All the forces that is acting in a same point, that is we termed as concurrent forces. Here 4 forces are there. All are having some magnitudes. 100, 200, 120, 50. So many values. So we have to replace all the horizontal forces. That is, horizontal force is nothing but we have to replace all the horizontal components. That is a cos theta. Cos theta. What are the forces that is acting towards right hand side? You have to take as positive. Negative side you have to take as, sorry, left hand side you have to take as negative. So simultaneously we are getting after summation we will getting a value 146.17 Newton. Similarly, sigma V also calculate the same manner. We have to consider the vertical forces acting along the y direction. Finally, whenever we are applying the formula R equal to root of sigma h square plus sigma v square, finally we will get the output, that is 160 Newton. As well as the direction also we will get 24.14 degree. This is the two values we are getting in this problem as the output. That is the result of this one. And the theta 1, theta 2, the angle is not given. For that, the formula is also introduced, the trigonometry. The basic thing, tan theta equal to opposite side by adjacent side. That is tan inverse of half, tan inverse of 4 by 3. We are getting 26.56, 53.13. The final result is, the values is shown in the slide. And Lami's theorem is a very important theorem. Lami's theorem represents, it is this theorem is applicable only for the 3 forces. The system of forces should be a 3. So then only this Lami's theorem will be implemented. How we are using this formula? A by sine alpha, B by sine beta, C by sine gamma. It is clearly mentioned 3 coplanar concurrent non-collinear forces on a body or in equilibrium, then each force is proportional to the sine of the angle between the other 2 forces. We can easily tell one force, we can hide it and we can see the opposite of that force is nothing but gamma of that F2. The same force, we can hide one force and see the opposite angle. Then we can write the formula automatically. This is a formula. Then based on the Lami's theorem, so Lami's theorem is, it is preferred only for the 3 forces only. More than 3 forces, what method we can go for means, that is a resolution method, what I have seen in the previous slide, what you have seen. Okay, so this is the Lami's theorem. It is applicable for 3 forces. Here that is 3 forces it is acting. We are taking a point C and the angle between 2 forces should know, otherwise we have to calculate. With calculation we can know the various angle between the 2 forces and finally we can use the Lami's theorem. Lami's theorem, what are the important conditions? We must know the angle between 2 forces. Then if one unknown is there means we can do the, with the help of the known value we can find the unknown value. With the 3 relationship we can use any one relationship and find the value. In this formula we are getting the 2 values, that is TAC and TBC. And here also another one problem, this is for your practice. Based on the previous problem, we can do this as a practice problem. In this, the 2 various joints that is given here, that is one is B and another one is C. These 2 joints are given. What joint is preferred first means B joint, because the number of known values are more, because the 300 is known, W2 we don't know and TBC also don't know. With the help of the 300 Newton, automatically we can find the other 2 values with the relationship. Similarly, after finding these values, we have to correlate with the next joint, that is joint C. Joint C. Again, we have to take that joint and you have to do the problem. First, we are taking joint C and second, we are going for joint B and finally, we are getting the output. This is one important, as well as this type of problem they will mostly in the part B or part C questions, bigger 15 marks mostly they will ask. Very important problem, as well as it's very simple problem only. By seeing the problem only, application oriented problem, but it is very easy method to solve this kind of problems. If you know the how to find the angle in between the two forces, then it is easily to apply the Lami's theorem. In these three channel of pipes, the three pipes that is dip, that is placed in a ground, underground. That is a cut section. Front view it is given over here. The problem is also given. The cylinder 100 Newton of 80 mm diameter are placed in a channel of 180 mm width. The width of the channel is 180, and various forces they have asked over here. Cylinder on A, B, as well as cylinder B on the wall also. The first thing, by the geometry, we must know, with the help of the diameter, we have to find the various distance. With the help of that only we can find out. OP is nothing but 40 plus 40, 80 Newton. Sorry, 80 millimeters. What is PS? PS is nothing but, we can subtract the 90 minus 40, automatically we will get 50. So finally, applying Lami's theorem, what are the unknown? We can see in the slide of the first, the middle part of that one. R2 opposite angle, R1 opposite angle, which is equal to 100 by sine 77.4. Simultaneously, we will get one value, that is 64 Newton. Similarly, we are going for the cylinder B as well as cylinder C. The same method we are going to implement. Again, using the Lami's theorem, finally we will get the output. Only thing, you must know the angle between the two various forces. Then the Lami's theorem will be applied. The few important topics only. With the help of the geometry of the figure. You must study the geometry first, the sketch first, then automatically we can find the angle easily. So now we move to the next one, important content, applications of engineering mechanics. Where it is used. Various civil, structural areas, mechanical, aerospace, biomedical engineering, buildings, bridges. Nowadays everybody aware of that metro work is going on everywhere. In this also, the civil engineering must know that how much force that is utilized in every joint and every support. Every calculation they will do. Without that calculation, they can't do any construction. With the calculation only, the building that is supported properly. All engineers will do that. So this engineering mechanics is a basic input, is a basics they have included in that. Various, if you are going for any construction work, this engineering mechanics concept will be there, as well as mechanical. When you are studying for the engine, various force will be acting on the engine also. Engineering mechanics is one of the important criteria that is acting on into account. So these are the various applications here we have focused on: robotics as well as spacecraft design, aerospace engineering, structural engineering, nanotechnology, everywhere, etc. So many applications are there, various applications. So course outcome, as we already focused on the what is the objectives of the course, we already seen. The same outcome, the students, finally after studying this course, the student must reach the how the vector and scalar representation of the forces and movement. They will study in that. Analysis and rigid body in equilibrium, they will get the more idea in that. The properties of distributed forces also they will learn. These are the output the student may get after go through the each and every topics of the unit what I produced in the previous slides. Then finally calculation of the dynamic forces also. So I really thank all students for the kind attention. So kindly go through each and every basics thoroughly, so that will be helpful for your academic growth. So thank you all.